Okay, so the next part is ratios. Now, did you do ratios at all last year? So, having taught year 8 last year, I found that there are certain topics that we don't have time for every year. Ratios tends to be one of the ones that gets cut. Um, so, we will have time to do it properly today and on Friday. So, think of ratios as a way of sharing or comparing two groups or two sizes. So, let's start off with an example. I've actually never made cordial before. No, because I just drink juice or soft drink, you see. But I hear that when you make cordial, what you do is you buy the syrup or whatever it is, and you add water. Is that right? All right. So in this example, I've said I'm going to make 500 mils of cordial by taking 100 mils of syrup and adding 400 mils of water to it. So I have half a liter of cordial overall. Well, so Ben has jumped the gun a little bit, but that's fine. He's a keen bean. So to start off with, I've asked the question: what's the ratio of syrup to water? It does. So here I've given you the setup. All right. So here I've said I'm going to add 400 mils of water to 100 mils of syrup. So I think I'll do this one for you. 100 to 400. Okay. Because notice the way I've asked this question. What is the ratio of the syrup to the water? So the syrup amount should come first. I've had it, like at school camps and stuff, yeah. But as, okay, so year 11s, have a look at the second question now. What's the difference between the two questions? I flipped the words water and syrup. Will this change my answer to the question? It will. So the first one, the first group, should be the first number. So this time I'm going to say 400 to 100. Okay? Because this time I've asked for the ratio of water to syrup. All right, so this is the first big idea. A ratio is comparing two groups, two sizes. All right, you okay with this? Okay. Let us proceed further then. You may have noticed I said add 400 mils of water for every 100 mils of cordial. So this was syrup, this was water. Could I have said it differently? Could I have said add 4 mils of water for every 1 mil of syrup? The numbers are different, but the ratio is the same. The concentration is going to be the same, those of you who are doing chemistry. So once we are happy to set up a ratio of two numbers, one of the questions that we want to ask is, can I decide whether two ratios are the same or not? Can I make this simpler? So for example, would you sort of agree that this one is kind of simpler? Maybe not to make, but in terms of the numbers being smaller. Like 4 parts water to 1 part syrup. That seems simpler in my mind to 400 parts water to 100 parts serum. Okay? These two are the same ratio, but somehow, if I can have a simpler representation, I'd like to go for that one. So here's the idea. As long as I multiply or divide by the same number on both sides, I'll get the same ratio. So what I'm seeing here is I can divide both numbers by 100. As long as I divide by the same number on both sides, I'll have the same ratio. So if you want to write this as a sentence, if you multiply or divide all numbers in the ratio by the same number, the ratio will be the same. No, all. Yeah. So I'll cross that out. All numbers in the ratio by the same number, the ratio will be the same. So my Year 8 class last year would have done something like this. They would have been given ratios that look like this, and I would have asked them to simplify them. So have you done this in your time at school? Okay. So we can do it together. So the trick is to, basically the strategy, I'll say, is to look for a common factor and divide the numbers in the ratio. So the first two are meant to be simple. So have a look at this first example here, 5 to 15. Is there a number that goes into both 5 and 15? 4. 5. Okay, 3 doesn't go into 5. Oh, it does, it just doesn't fit right. Yeah, so it would be considered a factor. Yeah. Okay. So yes, it is 5. So if I divide both by 5, yes. So I divide both numbers by 5, and I get 1 to 3. So you don't need to do the arrows, but this is how I taught it to my students last year. Okay? The important part is that I divide by the same number on both sides. Okay, what about part B? Okay, all the numbers are even. So 2 is going to be a common factor.
1, 5, and
Yep, so divide by 2, divide by 2, divide by 2. Most of the ratios that you will meet will just have 2 numbers in them, but we can have more than 2 if we want. It's up to us. Okay, and just because I can, I've put one with big numbers in there. So can you identify a common factor here? No, 4 doesn't go into 66. Do you know that 11 goes into 484? I think 6 won't go in, Jess, because 6 times 8 is 48, and I got 480 there. Alright, so let's try 11, okay? If I divide 66 by 11, I'll get 6, and if I divide 484 by 11, I'll get 44? Yeah. Can I simplify further? Yeah. How? Yep, divide by 2. Okay, so if you can't do it all in one step, just break it up. Can I simplify any further? 3 to 22. Why not?
Because you can do 1 to
3 is a prime number. There's no more factors to use. Okay. All right, so I'll just give you a few more seconds to get that down. Okay, this is the last part. So, I don't want to say bad news, but I guess this page is going to feel a bit harder than everything that we did previously in the lesson. And as I've worked through Year 12 exam papers, I've discovered that you are expected to be able to reason at this level next year. So if you're looking to do well next year, you will need to understand what I'm about to teach you. So, notice that I have now described my ratios using just letters, so primevals or variables. If I give you any two ratios, the question that I'm posing is, can I tell whether they are the same or not? You see, before, I had a ratio that was 3, and I could simplify it down. Now I'm going to give you two ratios, and I want you to tell me if they're the same or not. So I need a definition or a test that I can apply consistently to tell whether the two ratios are the same or not. So for example, if I give you 5 to 9 and 1 to 1.8, how do I know if they're the same ratio or not? They are the same ratio, believe it or not. Because if you multiply the right-hand side by 5, 1 times 5 is 5, 1.8 times 5 is 9. Okay? But if you don't see that straight away, you might think that these two ratios are different. So this is the reason why I'm introducing you to this test. Okay? And it involves fractions. So, two ratios, A is to B and C is to D, are the same when the following is true. A divided by B is the same as C divided by D. Your textbook doesn't really emphasize this much. It's buried in one small example at the end. Okay, so one thing that we might want to do is say that two ratios are the same and then find a missing number. You do need to do this on the assignments, and I can think of a question on the Year 12 exam where they needed to do this as well. So, the first one, part A, which is here, I reckon you can do that without using the fractions. Can you see it? If I say that these two ratios are the same, what value does x have to be? So we've got two very similar answers. All right, what's your reasoning behind 200?
multiplying by 10 with each number.
Yeah, times 10.
Times 10.
The first number.
And then 20 times 10.
Then times 10. So can you see here, I've multiplied both numbers from the left by 10. Okay, so x is 200 by this reasoning. Because to go from 5 to 50, I have to multiply by 10. Therefore, to go from 20 to x, I have to multiply by 10 as well. So x is 10 times 20. Here's how I want to teach you to set out your working though. So you're not going to do that. It's okay if you wrote it. You're going to do it this way. you're going to do 5 divided by 20 equals 50 divided by x. This looks like a linear equation for x.
So what did you just get twice?
Yep. So in other words, I'm going to write a different color to avoid confusion. X equals, I'm skipping a few steps here, 50 times 20 divided by 5. Okay. So the advantage of this approach is that I can do this for any number. At some point, I can't use my times tables for everything, right? I have really large numbers, like 397. So this method will work for any numbers in the ratio. Okay, can someone who has not spoken yet tell me the equation involving fractions that I should set up in the second question to solve for x? Ready?
5 over 20 equals
Yeah?
3 over x.
3 over x, very good. All right. Now, if you do the algebra here, you'll get x equals 3 times 20 divided by 5. That's 12.
What?
So you just do 3 times 20 over 5 on your calculator?
Yeah.
How do you know?
So I've actually done 2 sets of algebra here. Okay.
You know, you ever remember that? What is it, just like few times? Like, what's the top ratio for the number?
Yeah. So I think when I was at school, we did this.
Yeah, like on a diagram.
Yeah. So you move the bottom numbers up to the top.
Yeah, okay.
So 5x equals 3 times 20, and x equals 3 times 20 divided by 5. Yeah. So if that works for you, go for it.
I'm trying that down.
All right, and one more, the third one. Someone else tell me the fractional equation, please. Don't make me pick on somebody. Someone who hasn't gone. All right, speak up so I can hear you. Yeah. This might work. Keep going. So I think this might work. It looks a bit different. So this actually turns out to be fine as well. So, so Beck, can you see on the left-hand side you use these two numbers? Whereas in my definition here, I've used the numbers in the same ratio. Whereas here you use the numbers in different ratios. But it actually turns out to be fine. So you can do this as well. Okay? So I'll just say either this or this both work. And if you take 128 divided by 5, I believe you will get 25.6. Is that right? Yeah. So the very last question in the assignment, I ask you to give me a ratio where one of the numbers is a decimal point, has a decimal number to 2 decimal places. So to do the last question on the assignment, you will need to apply what we've just discussed here. Okay? And for some of the harder questions next year on the exam, at the end of the year, you'll need to know this as well. You'll need to be able to apply reasoning with ratios. Okay, are there any questions? Would you like me to go over anything again? Okay, so I've covered 1D now as well. Yes, Maddie?
Right, with question B, so you do that equation, and then if you just put then the yellow in the calculator, would that give you the answer?
Yeah.
12? Okay.
Yeah, but the idea is that either you've done some algebra or you can rearrange it in your head to go from purple to yellow. Yeah. Okay. All right. Thank you. You may now continue working.